Hello, welcome to our video today on the Pythagorean theorem and similar triangles. So the last couple of days we've worked with similar triangles, and you may have noticed that a lot of the similar triangles we worked with were right triangles. When things are right triangles, we can also use the Pythagorean theorem to find missing sides. So today we're going to go over how do you know when to use the Pythagorean theorem and when to use similar triangles, and what do you do when you need to use both. So for example, in this first problem here, we have two similar triangles. We have a small triangle here, and it is similar to this larger big triangle. We're given two sides, 3 and 4, and we're missing this third side. So, should I use the Pythagorean theorem or similar triangles? In this case, I should use the Pythagorean theorem. The way that I know is because all of the things that I'm given or trying to find are on the same triangle. So I'm given 3, that's a leg of this small triangle. I'm given 4, that's a leg of this small triangle. And I'm trying to find the hypotenuse of the small triangle. I can find that with only information given to me about the small triangle. I don't need any of the big triangle to find this. So when you have two sides on the same triangle, and you're looking for the third side of that same triangle, you can use the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. And if we recall, a and b are the legs, or the sides that are touching the right angle, and c is the side not touching the right angle. So in this case, I'm going to make 3a, so I have 3 squared, and 4 is going to be b, so plus 4 squared equals c squared. 3 squared is 9, 4 squared is 16, and that equals c squared. 9 plus 16 is 25, so 25 is c squared. Now to get rid of squared, you're going to use square root. I'm going to do the square root of 25 and the square root of c squared. The squared and the square root will cross off. The square root of 25 is 5, so I get that 5 is c. So this missing side here is 5. Now let's look at another example. If we look down here, this is the same triangle because I've still got that 3 and that 4. I have another piece of information here, that this side is 6, and now I'm looking for this longer side. Now, just given this information, I don't have enough to find this longer side. I can't use the Pythagorean theorem. In order to do that, I would need this side for A, and I need this entire side for B. I need this and this for A and B. What I can do, though, is use the information I got in the last problem. So in the last problem, I figured out that this side right here is 5. So now that I know that side is 5, I can use similar triangles to find the longer side. I'm going to make my small triangle new, and I'm going to make the whole big triangle old. So the big triangle is old. And I'm going to make a proportion using similar triangles, new over old. It's important that you match up the correct sides. So, new, this 3, this up and down side, would match up with 6, this up and down side on the old. So I can do 3 over 6. Now, do I use 5 or do I use 4? I would use 4 if I was trying to find this whole side, because that's the side that would match up with 4. Since I'm looking for this side, the hypotenuse, I'm going to use the hypotenuse of the little triangle. So I'm going to do 5 over, I'm going to make it x for the question mark. Then I'm going to cross multiply, and I should get that x equals 10. So that means the hypotenuse of this bigger triangle is 10. Let's look at a different example. So here I have two triangles. They're similar triangles. I think I would know for sure if one of the other angles was marked. So let's pretend that those are marked. Now I know they're similar triangles because they each have two angles that match. Now, should I use the Pythagorean theorem or similar triangles? I should use similar triangles to find the missing side of this, because Pythagorean theorem requires that you have two sides on the same triangle. So if I was looking for this third side here, I could use the Pythagorean theorem because I've got two other sides on that same triangle. But to find this side, I would need to have both of the other sides on that triangle. Since I don't know what this is, I can't use Pythagorean theorem, so I'm going to use similar triangles. So we're going to make a proportion. I'm going to pick a new and an old. So this is new, this is old. I'm going to see which sides match up. 4.5, the up and down side, is going to match up with 1.5, this up and down side. So 4.5 over 1.5. And then 6 is going to match up with my unknown side. So 6 over x. Then I'm going to go ahead and cross multiply this to find the missing side. And I'm going to get 2. So this missing side is 2. Now, if I look at this next example, same triangles. I'm going to again mark the second set of angles so I know they're similar. Now, looking here, we have a problem. We're looking for this missing side. I can't use Pythagorean theorem because I don't have two other sides of this same triangle. I would need this and this in order to find this with Pythagorean theorem. I can't really use similar triangles because there's nothing on the other triangle that matches up to this. 1.5 matches up to 4.5, but this question mark doesn't match up to anything here. However, I just found out 2 in the other problem. I found out that this was 2. So I can bring that down and put 2 here since they're the same type of triangle. And then now I can use Pythagorean theorem because now looking here, I have two sides of one triangle and I'm looking for the third side. So I can use Pythagorean theorem, a squared plus b squared equals c squared. A and b are the sides touching the right angle, so 1.5 and 2, and c is what I'm looking for. So I'm going to do 1.5 squared plus 2 squared equals c squared. So I'm going to square 1.5, and I get 2.25. So 2.25 plus, I'm going to square 2, and I get 4 equals c squared. I'm going to add 2.25 and 4, and I get 6.25 equals c squared. And then to get rid of squared, you use square root. So we're going to do the square root of that. So over here, I'm going to do the square root of 6.25 equals the square root of c squared. Square root and squared cross off, so there's just c. And the square root of 6.25 is actually 2.5. So this missing side now is 2.5. Okay, I hope you enjoyed this. You'll get better with practice. I know it's confusing at first. If you get stuck, please go ahead and email me. Have a wonderful day.